Okay, so this is number 6 from your homework, and it asks you to figure out whether this converges or diverges. And if you'll remember, I gave you a few hints on here. I said you only know a couple of things. You know, if it's a geometric series, you can figure out if it converges or not. This is off your notes. You can figure out divergence by the nth term divergence test. The nth term divergence test never tells you that it converges. It only tells you if it diverges. And then there was this little guy right here, which says factorial functions grow faster than exponential functions. So that was like your clue. Okay, so for this one, given that I've told you that the factorial grows faster. Okay, did they ask you to do the first couple of terms? No? Is it sometimes helpful? Okay, so we could try. Okay, so if we put in 1, we'd have 1 factorial over 3 to the 1. Put in 2, we'd have 2 factorial, which is 2, over 3 squared, which is 9. Put in 3, we'd have 3 factorial, which is 6, over 3 to the third. Okay, then 4 factorial, so that's 24 over 81. Then what do we need? We're up to 5. 5 factorial, 120. Somebody tell me what 3 to the 5th is. Yes, really? No? Okay. Well, I'm not sure either. So sometimes when y'all don't sound sure, I'm not sure I should make sure. Okay, and then this would be times 6. Is that 720? I'm kind of going for a while here. 3 to the 6. Can somebody help me out with that? Okay. I'm still going. I'm on a roll here. Because basically, I'm trying to prove to you numerically, this is my goal here, that this numerator is increasing faster than the denominator. Okay, so I'm on 1, 2, 3, 4, 5, 6, 7. Somebody's going to have to tell me what 7 factorial is. Okay, that's a help. Yeah, I was trying to pull up the. You found it? Oh, not there. Sorry. It's the one with the to the left of the G, to the right of the G. It's that got the factorial on it. Okay, so it's what? 5,000. Got it. Okay, so if you're kind of looking to try to see which is outpacing which between the numerator and the denominator, okay, I mean, at first, it clearly looks like the denominator, right, is larger. But then as you keep going, what's happening? Okay, so what we're going to be doing here is you're looking at the sequence. Okay, so I'm looking at the individual numbers. And it's basically like your horizontal asymptote rules where you're comparing degrees. When you're comparing degrees, you're trying to decide which one is growing faster. Okay, so if the numerator is growing faster, what is this overall number going to go to? Infinity. If the denominator is growing faster, what's the overall number going to go to? 0. Okay, and so I just wanted you to use your knowledge of the fact that factorial grows faster to look at it, and I'm also trying to prove it to you numerically. And it looks like it now. It's not like super fast. This isn't a huge number, okay, but it's definitely starting to outpace. So that equals infinity if the sequence, if these aren't getting smaller and smaller as you go. If the sequence numbers aren't getting closer and closer to 0, then there's no way that when you add them all up, it's going to converge. It's just going to explode. So since the limit as n approaches infinity of the sequence is going to infinity, which is not 0, you can say, therefore, the series diverges by the nth term divergence test. And you do have to say by what test, because we're going to have a lot of tests, so you can't just say diverges.
Okay, so number 5 is the sum. This one. So just looking at it, I can already tell that it's going to oscillate back and forth positive to negative because it's -1 to n+1, so I know it's gonna keep going back and forth, so we just have to see if it's just like going back and forth from like one number and just not converging to anything, or if it's actually ending up converging to something, even if it is both sides are converging to it. So I just put in the n's and found the first few terms to figure out u sub 1 and r. So I'm just going to go ahead and do that. So just looking at that, I can already tell that even though it does go back and forth between positive and negative, it is getting smaller and smaller, so it's going to be converging to 0. So I know that it will be able to converge, and so u sub 1 is 3/2, r is just -1/2. And so another way you can tell that it converges is because the absolute value of 1/2 is less than 1. And so you already know that the series converges by the geometric series test. And then because you know it converges and you have r and u sub 1, you have to find what it converges to. So the sum is 3/2 over 1 plus 1/2, and that's just 3/2 over 3/2, which is 1. So it converges to 1. Yeah.
Okay, so this is your new best friend. I am not suggesting that you get rid of your old best friend, the formula sheet, but you have to memorize this. Oh, you just told me I didn't have to do that. Okay, so here we go. He's trying to give me a hipper look here. All right. So the tests we learned already, we've got the nth term divergence test and the geometric series. So those are the only two you know so far. Okay, who can tell me something about the nth term divergence test? All right, Jack. Only used to show divergence. Good. So I can't prove anything converges with this. Okay, if I take the limit as n approaches infinity, this is of the sequence.